thank you everybody for having me here today. As Heather introduced me, I am part of Dassault Systems. I've been with Dassault Systems for just almost 7 years now. And so we should have some fun with this data set today. You guys are in a great place for in the location you're at live, all right, is a great spot for where part of like this demo set that I have here. So without further ado, let's jump into it. So again, that's me. If you want to get in touch with me after this, you have questions about anything related to electrical at all, that's my Twitter account plus my email address, of course. And of course, the rest of the Swuggen guys know how to get in touch with me as well. This is my counterpart. So I'm based in the East Coast, and with Dassault Systems, there are two of us. We cover all of North America, and with TPM, with Trimec, with the rest of the resellers, we are the first line of defense when it comes to trying to help out and make sure that you guys, everybody out there, is successful with the electrical tools. I always like to start off with a nice little icebreaker, nice little thing. I found this on Google, so if you want to find this image later on, this is what I picture. If you had to name this image, this is what's going on in a mechanical engineer's head when they're talking to an electrical engineer. It's just one of those things. I'm an electrical guy, right, at heart, so I like to poke fun where I can every once in a while. So I think my favorite piece of circuitry in here is the flux capacitor down in the bottom left. So just to kind of familiarize yourselves with SOLIDWORKS Electrical, if you're unfamiliar with it at all, right? The typical CAD design, right, the 2D side of the world, you know, companies are using things like Visio or just Excel or Paintbrush sometimes I've seen, right? And they're drawing that stuff out. And they're adding blocks and they're drawing lines. And then they're taking all that and they're capturing the data that goes with that drawing in something like Excel. And then after that, they have to go back in and redline that, second check it, make sure everything is right during that audit process. So what SOLIDWORKS Electrical allows you to do is it allows you to take that reporting and that auditing, the design rule checks, and allows you to bring it up front while you're doing your design. So that way, yeah, your design may take a little bit longer to get done because now you're adding all this extra data up front, but now you're not sitting in front of Excel for 6 days making sure you order the right pins for the connector as you get ready to purchase all that information, all that stuff. So within SOLIDWORKS Electrical, I like to call it the key factor. No pun intended with this connector we have here on the screen, but the shared library, the manufacturer part library, and all the metadata built into every single one of your parts, that is the main hub of information, for lack of a better term. And you can see here this one connector, right? There's a lot of different ways I can represent this one particular connector. Today, we're going to really focus on the line diagram, the schematic. We'll actually cover all of them, but the main ones there are the detailed schematic and, of course, the 3D model, which what everybody wants to see. So SOLIDWORKS Electrical works in conjunction with the 3D side of the house. And in the middle of the screen where those two green boxes are, right, we call that the component tree. It's not your feature tree, but it's the component tree of all the parts you're going to use in your particular project. And you can see on the left-hand side, I have the electrical pump, right? And on the right, I have the actual 3D model of that. So if I'm the electrical engineer and I know what pump we need, well, I'm going to go ahead and add that symbol down. I'm going to assign it a component. And now on the right-hand side, all I need to do is simply insert that. And we're going to do this later when I get into the actual live demo. But maybe the electrical guy doesn't know what type of pump needs to be inserted or motor, right? Maybe the mechanical side is the one speccing that out. Well, they can go on their side and add that component, add the model, and now on the electrical side, all I need to do is say insert symbol. I don't even have to think about it because all the metadata is already built into that component that you've already added to this component tree. All right, so we're here, we're at a brewery, right? It's a little early in the morning, right? It's 9 o'clock for most of us here. Unless you're watching from the West Coast, it's way early, but we're gonna talk a little bit about beer. We're gonna talk about electrical and SOLIDWORKS. It's going to have to do with beer a little bit. So if you've ever started brewing beer, right, if you've ever tried to brew beer, you might have gotten something like this as a Christmas gift. right? That's what I got when I first started trying to brew beer. I think actually Heather's husband Earl probably started with one of these. And then you graduate, right? You're like, I like this. I'm going to go on. I'm going to try a little bit more, try some different styles. And you graduate to something like this. And this is actually what I have right now. I haven't used it in a while. My wife hates the smell of it in the house, but you know what? It's good. So if you get really good, like Heather and Earl, you end up purchasing something like this. And then you have these huge kettles and you have this electrical panel to start out with. And this is an electrical home brewing kit. So what I did here, and this is just another quick example from electricbrewery.com of the guy who has this huge website. Just a quick plug to that guy. He has all these parts listed on his site. So if you ever want to try to build something like this yourself, that's a great spot to start. He has every single part listed down, like Amazon if you want to go there, how to put things together, how to solder, right? If you need to. I took that data set and I digitized it and I turned it into what we're going to be working with today. And the reason why I did a lot of this is because, we always really try to connect it to things that maybe hobbies that we have at home. Like I've designed uh, a guitar in SolidWorks, and it's not a very good model, but it was one I was practicing with. And then something like this, where something that we want to do at home as a hobby, and I was trying to connect those two together, those two worlds, the business side and our home side together. Um, so what we're going to work with today, this cabinet here, and some of the things that we're going to have to do during this is we're going to continue our 2D design and utilize a lot of the intelligent functionality within SolidWorks Electrical itself. And then we're going to take those and we're going to do what I said before in that slide. We're going to link that information over to the 3D side. And then we're going to route our wires. And then we're going to generate the important stuff, right? The meat and potato. Like we built all this stuff. Now we need to be able to create a report to give off to our contractor or whoever it may be later on. So with that said, we're working with a home brewery today, and I always get this, and people give me that look of like, yeah, well, we don't do home breweries here, right? Maybe we design something like that, this frozen drink machine on the left, or maybe you're a mil spec guy, DoD somebody or other, right? And you do chassis design. So all the functionality that I'm going through doesn't necessarily always have to do with home brewing, right? It's more in line with how the tool can work for you. So just a few examples of things of different types of designs that people have done and made that to show that it doesn't always have to be this one little niche. It can be a whole bunch of different things, and ultimately comes down to creating the right drawings and everything else like you might see here. So let's go into it. Let's go live into the software. And I'm going to start off right in SOLIDWORKS itself. I am currently on, I believe I'm on 2022. I go back and forth a lot because I do some testing and stuff too. Yes, I am in 2022. So, sneak peek, don't tell anybody. All right. So, first thing we want to look at when we first open up and we're connected to SOLIDWORKS Electrical is we have our electrical project manager. Now, what is the electrical project manager? The electrical project manager contains all of the projects that have connection between the electrical and mechanical space. If you're just working mechanical, it doesn't have to be in here. But once you want to try to connect it and do any type of collaboration between the two, you'd want to have it connected in and associated and managed in this folder here, this GUI here. So we already have it open. You saw that our project that we're working with is in blue. Once we have that open and we have the add-in turned on for the SOLIDWORKS side, we have our electrical tab available to us where our toolbox would be and everything else. Now, why am I bringing that up? Because there's a folder structure that we have here. Now, this is very basic. You can organize this, right? This is just me working, making a fun demo set. But if this was for a legitimate business, right? Maybe you have a book with folders and subfolders and a lot of different types of ways. It's totally customizable. However, you want to organize your information for your projects or for your company, come up with a standard, and you can build that into what we call a template, which I'll show you later. All right. Within this document tree, right, I said there's a lot of different types of folders and whatnot, but one of my favorite things about this is that I can actually embed a spec sheet a PDF, right? Word document, whatever it may be. Oh, popped up on my other screen. I can embed that right into the project. So now instead of me having it and downloading it locally to my computer or uploading it into some big spec sheet folder we have up on our server, I can actually create a shortcut, link it right to this project. So if I'm out in the field and somebody else needs to continue the project, they can figure out the wiring and the specs for that particular part moving forward. So it just helps to start to collaborate a lot better and move things along to get the project out the door faster. All right, so we have our project here. One last thing on this side, as a mechanical engineer, right, and I have this available to me, I can also go in and view the progress being made. I can't edit the schematic from this side, but I can at least see what's going on and see, oh, that's what he's talking about with P1 or J1 or PLC2, whatever it may be, right? So you can kind of get an idea, and again, keep that communication bridge open from one side to the next. So let's go ahead, and I am going to open up SOLIDWORKS Electrical, brand new instance. And when I first open up SOLIDWORKS Electrical, well, the first thing that pops up, well, that project manager. Reason why I showed you that before. And this time we can see that it's in red, right? That project that we're going to work on is in red. Well, that lets me know that somebody else on my team, it's me because I'm in a standalone setup right now. I'm not in a network setup, but it lets me know that somebody else is working on that project, whether, John, the mechanical engineer, whoever else, but doesn't stop me from opening it. And now I can go in and I can start making edits to the schematics on this side. We can also see that because I do have it open on the mechanical side, it shows up in red here, letting me know that, that it's being worked on. So within SOLIDWORKS Electrical, I mentioned earlier in that key factor slide, right? There's different types of symbols. Well, there's a line diagram, which is kind of like a block diagram, right? Just a box and lines connected to it. And in this case here, we have different types of sheets, a line diagram sheet or block diagram and a schematic. So just a quick view. We're going to go back through this again in a minute. But this is really where you would maybe want to start your project. You don't have to, but your line diagram, right? I like to use this more of a high level overview drawing, something that we're going to use to kind of just get like the main pieces of our project down on a sheet, because once we start adding stuff to here, we're also building that component tree as well without having to really get into the nitty gritty of all the pinouts and what kind of wires we're using, right? We know we need this PLC, we know we need this type of contactor, whatever it is, we can just get that in here. And by doing that, it's adding it to the component tree, which means it's already building our bill of materials. And then the other type of sheet we have that we like to work with is just a standard detailed schematic sheet. And that's what we're going to start with today. So when we draw our wires out, all right, I already have this set up so we don't have to start from scratch here. But we have our wires. And with drawing wires on a schematic, we have two different ways, right? If you're doing a lot more higher voltage, higher power kind of stuff, then maybe you want to draw something like a bus, and you can use multi-wire styles. And in order to do that, I'm simply going to choose our multi-wire style, and I can drop it in place. Left click, and I've got it in place. Now, one thing really nice about the multi-wire style, you can see on the left-hand side here, I don't always have to choose all four of them. This is customizable. Maybe you want to show all eight cores in a Cat 5, right? So you can show that if you want to, or maybe you have it set up and you've built all eight, but you don't want to. I'll zoom in here for everybody on that screen that you've got there, but I can turn them on and off. Maybe I only want to show 2 pair out of the 8 in this particular instance. So I've already set it up that all 8 are there, but visually I don't want to show those other 2 pair or this single, this phase in this instance or something like that. So there are options in that aspect as well. The other really nice thing is that maybe one connector here it's 1, 2, 3, 4. On the opposite side, it's 4, 3, 2, 1. Well, with a simple click of the space bar, we can flip that around if needed, and you can toggle the wires from top to bottom. Right. So besides drawing multi-wires, right, we want to draw single wires. And you can see that I drew a lot of different single wires here. But we don't really have anything to add single wires to yet. So let's go ahead before we draw those single wires and let's add a symbol to our schematic. So you can see here that I have XLR1, this probe connector, this plug, and it's going to connect to this receptacle on the opposite side. So we're going to add another one right below this. So in order to do that, I have a couple different options. I could go and use every engineer's favorite functionality and give themselves a hand cramp is the Control C, Control V, right, and drop that into place. But I'm trying to show you some of the stuff that you can do with this tool, and we'll go ahead and just simply insert symbol. Now, the last symbol I used happened to be this terminal block symbol here. So if you're trying to add several symbols over and over and over again, this is a nice little thing where I can just hit insert symbol. Control R is repeat command. So Control R, drop that symbol in, add, J1, whatever the component tag you want for it. Control R again, and just keep moving forward. You could also use the copy paste method if you really wanted to, but just to show you that there's different options available to you. So I'm going to go ahead, search for this particular connector. Now, once I'm in this window, this is called the symbol selector. So this is going to give me a giant list of pretty much every symbol I have in my library. And I can pick and choose which one I want. These categories here, these classifications on the left, help you kind of organize all your different types of symbols you might have. I know it's a connector that I want to add, and I'm going to go ahead and drop this into place. At this point, now we can go in and define what this particular symbol is going to be used for. I've already preset up that every time I use this particular symbol, I want the root to be called XLR. It doesn't have to say that. It could be J, it could be P, it could be CN, whatever you want it to be. You can set that up as the default for it. Again, helping you move along from the standard default. I think the default was X for just a connector. This is where you would want to add information about what this symbol is being used for, right? In the case of this, it is the mash probe. So I'm just going to simply go ahead and type in mash probe, and now we can assign an actual manufacturer part. I'm going to clear the filters out of this. SAPT. And now with this, I can still search for a manufacturer part based off those classifications, right? But if I don't know the exact information, I can always filter it out. So I'm going to filter out to just connectors, and it automatically filtered out to connectors because I picked a connector symbol. It's not going to give me a contactor when I've picked a connector symbol. It's going to help me try to narrow it down to find my search. There are some filters in here when you're searching for manufacturer parts. Maybe you don't know exactly what kind of pump you need or what kind of motor or what kind of power supply. So based on the metadata built into the manufacturer part information, you can start to narrow it down to a few and then pick the right one that works for that particular job that you're working on. I know that this is the part that I want. I'm going to simply add it down here. This particular connector in reality actually has solder pockets rather than different pins. So I only need the one part, the housing that has the pins built into it. And we can see that I have my part here. And just like that, I now have XLR3. Pretty straightforward. So now let's go ahead and let's draw those single lines. So instead of drawing the multi-wire, using the multi-wire option, we have the single wire option here. And this little window here is what we call the wire style selector, which is pulling from our wire style manager. So inside of SOLIDWORKS Electrical, every project, right? It's not global, but in the project itself, there is you have a different variety of wires that you can customize, right? So if you start blank, you're going to have no wires in there. So depending on who your customer is or what your standard is in your office, you want to help build this out, right? And maybe you want to set up your wire styles based off of gauge, right? That's a big one. That's how I usually recommend most folks set up their grouping here. As far as, set up all your 14 gauge, black, red, yellow, green, purple, blue, polka dot here. And then the next group is maybe 16, 20, 24, whatever you use. That way it's easier to find. And the reason for that is because which we'll take a look at in a minute, is there's a lot of metadata behind the wire types. They're not just lines on a sheet. So let me go ahead and draw these out real quick, and then we'll show you what I mean. So I'm still in the command, and I'm going to go ahead and draw these 3 different wires out so I don't have to constantly, they're trying to get nice and clean. The developers are working on SolidWorks Electrical, they're trying to get to the point where we almost have the same thing like what mechanical side has, like the breadcrumbs, right? Where you can hit the S key and bring things to your fingertips. You're not constantly scrolling around. So that's still in the works. It's something that they're thinking about and trying to figure out a way to do that for us on the electrical side of the house. And let me go ahead and draw this yellow wire. And now I have, oh, where'd my other two wires go? What did I do there? Oh, I know what I did. Stand by, 2 seconds. I'm going to redo that guy. I have it set the wrong way. You tell I've done this once or twice. Found that pretty quick. All right, let me do that again. So I'm going to draw my blue wire. I'm going to draw my green wire. I was wondering why my font was going backwards there. All right, so now I have my XLR3. I can go in and add that description. I'm going to save us some time and not have to go back in there. All right, so now I've got this particular symbol here. And maybe this is something we want to reuse down the road, right? Again, Control C, Control V, but that only lasts as long as you have your computer turned on, right? And as soon as you turn it off, that Control C, you got to come back into the project and redo it again. Well, you don't want to do that. So we have this feature inside SOLIDWORKS Electrical called macros. I personally like to call them common schematics, something that I'm going to use over and over and over again, and not just for this project, but for projects, older projects, newer projects, whatever it is. Now, in order to create a macro, what I'm going to do, you can see I've done a couple of them here. I'm simply going to highlight the part, in this case, the symbol with the wires, the pigtails coming out of this right now. I'm going to highlight it and I'm going to drag it over into this macros palette. Okay. I can give it a new name. I can add it to a specific library. I can give it a description. And I've saved it off to my database. So inside of my database, right, we have a symbol library, we have a manufacturer part library, we also have a macros library. And that part is now a part of our library. And which means that anybody who's connected to our collaborative server, as soon as I create that, it's available for them to use. So you can have one person sit there and just make these circuits, all these little mini circuits here. And now when you're ready to, you can just add them to your window on the side here. And I can take that and drag that back into place. And just like that, I have a new instance. So I can do that as many times as I want, right? I can drag that in, hit finish, drag that in, hit finish, and just keep adding them. Because the nice thing about that is it's not just the graphic, it's all the metadata built into it, right? I mentioned that the wires have information, properties built into them, right? So it's the symbol information, the manufacturer part that we have in there, any of the description information or any other customized stuff, plus all the wire information on here too. And that wire information, right? We have the blue, it's a blue line, continuous line. There's a formula which we'll get into later. But physically, what is that wire type, right? In this case here, it's a 22 gauge blue wire. And if I was working with something like fiber or RF, these are things that you might want to account for, right? Because, or something like a 14 gauge or something like that, those have a higher bend radius. And you don't want to snap fiber, and you're not going to be able to bend a 14 gauge wire like you would a 22 gauge wire. So you might want to add that. And the reason for adding that is because those numbers are accounted for when you route your wires in the 3D space, but also you can have them set in a report if you needed to, or design rule check too. You can also, again, customize your wire information. These are different wire customization fields that I've created. I used to do a lot of RF work when I used to work for the Defense Department. And so impedance was important, the dielectric type. You can see at the very bottom there, I have mode and wavelength for fiber, right? Is it multi-mode or single mode, things like that. You can add that in and make that a part. So that way you can also add that information to your reports downstream. All right, so now we have these two additional connectors. Oh, and one more thing about macros that I really like, right? I just added a symbol, one symbol and three simple little wires, right? Well, maybe maybe this is my input circuit and it's the same from project to project or very similar, right? Maybe it's not exactly the same every single time. Well, I don't want to have to recreate or go back to that old project, copy it, bring it in and edit that. Why not create a macro out of all of this stuff? And now I can drag this over. And now when I'm ready to, as soon as my computer catches up with me here, there we go. I can go in and I can drag that into place over here, right? And now by doing that, I'm not going to do that because it's going to add all those new components to my project. But think about that real quick. You have how many connectors are on this screen? How many pieces of manufacturer part information? All these origin destination arrows, as long as they're on the same screen. Again, all that information that is captured in essentially a new symbol. It's a circuit, right? That's saved off that everybody can use going forward. You can always go in and edit that, right? So maybe you copied this, you can open up that macro, edit a couple pieces of information, add some notes, add some more parts to it, whatever you need to do, and it saves that there. And that way you can keep revising that macro rather than going back, copying and bringing it up. All right. So now we have on our screen, we have these two connectors and there's nothing connected to them. So let's go ahead and add some origin destination arrows, some to from arrows to connect these to another sheet. So in order to do that, we have to use, well, our origin destination arrows manager. So I'm going to go ahead, let me try this guy. Oh, my arrows are messed up. Sorry, 1 second. There we go. So let's go ahead and do some single insertion. I'm going to go ahead and find the next sheet that I want to connect these to. And we can see here that I have my blue wire and my blue wire for kettle 2. Now, the nice thing with this is, remember those properties, right, that I said that's built into each one of these wires. So I'm going to go ahead and select this one. If I try to connect to my green or yellow wire, it's not going to let me. It's not going to let me because it recognizes the properties are the same. So if you're like me, that you've been, it's like Friday afternoon and the mechanical engineers are finally done. Sorry guys, I got to poke fun where I can, right? But hey, okay, I'm finally done. Oh, tire schematic to reverse engineer this or something like that before we get done for the day, right? So instead of trying to draw everything out and then you don't realize that you cross connected something, you don't find out about it 2 months later. By using this tool here, it's a nice little built-in check that allows you to and helps you not cross connect things by mistake. So go in here, I'll go ahead and and if you're already using SOLIDWORKS Electrical, this is something that they fixed, which is nice, is that it used to it used to zoom out. It used to zoom out all the time when you do one and it would zoom all the way out. They fixed that, so it doesn't do that anymore. So I'm gonna just do this one. We can go here and now double click this, and you can see that it takes me to the opposing page with that. The nice thing with these arrows as well is that they are hyperlinked in a PDF. So when you export this project to a PDF, so instead of being out in the field with a giant 11 by 17 book and sitting there with your fluke trying to wring cables out, trying to wring any wires out, you can now have like a ruggedized iPad. Simply double tap and it'll tell you where it's going on the other end. All right, so I'm going to save us some time and not go do that one. So we're pretty much good on this side. Let's go ahead and take it to the next step, because I know there's a lot of people who might do something like terminal blocks, right? That's a huge thing in our cabinets if we're doing cabinet design. Maybe we're not even doing cabinets. Maybe it's just something that we're using terminal blocks in our projects for whatever kind of chassis we're working with. So in order to add a terminal block, we have two different options. We can add the individual terminals, right, throughout our schematic, or in this case here, we have this nice ladder set up with our PLC. And I'm going to go ahead and draw this into place. So go ahead and drop this terminal in. Now this little arrow here that you see on here helps us determine what side we want pin 1 to be on. When I used to do like real design work, when I was in the field, pin 1 was always on the inside of the cabinet. That may not be how you do it, but pin 1 was always inside. So in the case of this, the PLC we know is inside our cabinet. So I want pin 1 to be there. So the PLC is going to connect to that, go to the terminal, and then go out to the sensor, whatever it's connected to out in the field, right? Whether even if it's inside the box on the top, maybe we mounted up and cables went out the top. We reversed it so the pin 1 was in the bottom and pin 2 went up and out. That's just, again, that's how we did it. You don't have to do it that way. So I'm going to go ahead and say pin 1 is there. And just like that, now I have terminal block 3, 1, 2, 3, all the way down through 8. Great. Okay, cool. So I did that. I've got some origin destination information. Let's take this a step further. For no other reason other than to show you some of the functionality, I'm going to take these wires and I'm going to take these 4 right here and I'm going to turn them into a cable. So all you need to do is in order to turn these into a cable, is I've drew them out. You don't have to do it this way. This is just one way that a lot of people do it. You're administratively taking these wires you have and turning them into a cable. I'm not redrawing this on another sheet. You can if you want to, but you don't have to. And you can simply highlight the ones you want to turn into a cable. So I'm going to take these 4 and say associate to cable cores. I've already added a cable to my project. Just like adding a new manufacturer part to a particular group, maybe this terminal is a 2 level or a 3 level. I can go ahead and do that. And I've added that as well. So great. I've added all this information. It's not really displaying on my schematic like that, right? How do I know that that's a 3 level? Well, there's this option here to generate drawings. And I can go ahead and let the software use a configuration. SOLIDWORKS Electrical uses some configurations to allow us to automatically create things. So it's essentially a report of that terminal block. So instead of handing somebody a schematic and say, here, figure it out, you can also generate this drawing and say, all right, this is terminal block 3. You have a starting point, right? You've got a blank cabinet. You got to start somewhere. Well, you can go in here. You have your terminal block. You have your ins and outs from that terminal block. But why did I create that cable? Well, it's because we can see that I have the wires coming out of the terminal block, turning into a cable, all the information about that cable back out to the wires again, the cores of that, and then to the individual parts that it's connected to, including all the manufacturer part information about each one of those parts if I have it. I only did the one just to show it. But you can see here that I've got a lot of different data that I didn't have to have 2 screens or even 3 screens. I've got 3 screens here, but I didn't have to have my schematic up and try to redraw everything over here and then go back and try, right? I created my schematic, I set and added all the information I needed, and I simply hit generate drawings and it created this for me as needed. Okay, so now that we've got that, we've talked about our terminal blocks. Let's jump into the 3D side. We're pretty much there with our 3D model as well. And then we'll come back into this and generate some of our bill of materials, our 2 from wireless and everything else. So let me close this guy. And, all right. So we're back on our top level assembly. So one thing this is kind of a teaching thing too. I know that's why a lot of people like to join the Swugin, right? To learn something new about it. So with SOLIDWORKS Electrical, I'll bring this back up again. With SOLIDWORKS Electrical, we have in our project, we have the ability to define locations. Okay. And some people, I was guilty of it too when I first started. I was like, yeah, locations, okay, great. It helps me figure out my reports and stuff. But then as time went on, I was like, well, you can actually set up your projects based off of these locations and assign your top level assembly on the 3D side, and all your sub assemblies to different locations. And the reason I would recommend doing that is setting up those different sub-assemblies. Let's say you're working with a crane and you have, the cab for the crane, right? That could be one sub-assembly. Within that cab, then you have the chair, maybe that has its own sub-assembly. So you can create a location for each one. So that way, if you need to, if the mechanical or electrical guy needs to open up that 3D side to do any type of routing or anything like that, you're not opening just the top level and locking everybody else out, right? Because that's just not cool for everybody on the team. So setting up these locations ahead of time when you first start a project really help to make sure that you're not going to piss anybody else off, but it's just going to, the information flow is going to move a lot better. So with that said, I do have two different locations, and I have my top level assembly and I have the control panel as a separate one. I probably could have created one for each of the kettles and stuff, but we're really not going to work on the kettles today. All right, so inside of here on the top level, we have our cabinet, and we can see on the bottom of this cabinet here, I've got a couple different connectors. So I mentioned earlier that we also have our component tree, right? We have the feature tree. I've tried to clean this up so it's not just a mishmash of parts everywhere. But I also have my component tree that's tied to my electrical project. Now, as the electrical engineer, I'm going to focus most of the time, unless you're really good, you're gonna focus really on the 2D side, right? When you look at the 3D side, most folks go, I'm a 2D guy living in a 2D world, or I'm a 2D girl living in a 2D world, right? They kind of get scared looking at this side of the house. Whereas most of the people probably watching this love this side of the house. I actually really enjoy working on this side too. But they get scared. The electrical guys usually like, I don't even know where to begin doing anything. So there's a couple different options for making sure you associate and give that handshake between the electrical side and the mechanical side. And so what I recommend a lot of times is let the mechanical guys, you guys go in and you know how to use, if you got your little space mouse and everything else, you can mate everything up really quick using smart mates and whatever else, which we're going to use here. But with SolidWorks Electrical, what I would recommend, let the mechanical guy put everything in, right? He may not know exactly what that part is, P1, P2, J1, J2, right? But I know as the electrical guy, I know what that is. So I can still open the project. And there's this option here called associate. Rather than me having to go in and insert and it goes off in space somewhere and I got to pull it over and, all these different kinds of mates, I'm simply going to let mechanical guy do it, say associate, find the part I want. You have the option of either hide, or I'm going to go ahead and say show associated as transparent. So any of the parts that are already associated to something, you can't pick. So in case of these, it won't let me. I know this is J2. I'm simply going to highlight and hit the enter key, and I've made that handshake between the two sides. It's super simple. Associate works really well and helps get the job done a lot faster. Now, besides that, you also have the ability to insert, right? Maybe you aren't that bad at the, try to give everybody some credit here. Maybe as the electrical guy, you can dive into here and maybe cause some damage, but uh, you have the option of going in and inserting. And so in this case here, I have my part. Let's see if it'll let me do it. And I've already noticed it snapped into place because, well, I was smart enough to put and do my smart mates and set up all that. So I'm going to go ahead, drop that into place. And I'm going to do the same thing with XLR5. These are the connectors that we just added to our schematic on the other side. There we go. Oh, there it is. So it's pretty straightforward to add our parts, right? Now, there are a lot in this data set. If we had another 2 hours, which I'm not going to do that to everybody on the phone and talk about electrical, we have our main power coming into the box. We have all the hoses that are connected here, and connect to our pumps, as well as our chill water, everything else that we have here. There are a whole bunch of other aspects to it, but let's focus on our cabinet. So I just wanted to touch on adding our actual parts and connecting the electrical side to mechanical. So now I'm going to go ahead and jump into just the cabinet itself, the control panel. So give me a second. Let me get a sip of water. Eric, are there any questions, by the way? All right, I'll take the lack of answer with no questions. All right. So you can see there that I'm closed out of the top level, and I'm just going to open up the cabinet itself. Give this a second to open. There's a lot of parts in here. I get a little carried away when I did this. I even added all the screws. I tried to add everything into this as well. I wanted it to look pretty. All right. So now we have our cabinet. Now, hide that guy right there. We'll talk about that in a minute. So I've got my cabinet. I've got most of my parts set up. Now, how do I get my wires to route? Well, we've already added our parts. We've made the handshake between our electrical side and mechanical side, but there's still some things we need to add to our parts before we can actually just route, right? If you're using SOLIDWORKS routing, right, C points, that's what you would use. But for SOLIDWORKS electrical, we have connection points, but there we don't use the C points that are for the electrical routing portion that come with premium routing. So to kind of highlight that for a second, each one of our models, right? In this case here, what I've done is I've already took this part and I added the fork terminals in here to kind of just clean it up a little bit. I didn't want to. I wanted to show the detail, but I did not want to show every single ring terminal as its own feature in the feature tree. So in this case here, I turned it into an assembly, added them all, and then turned it into a part. And it works fine for what I need to do. In this case here, you can notice that instead of it saying C point, right, it has a 0_2, a 0_3. Hopefully everybody can see that on their end. I'll zoom in a little closer. Unfortunately, the numbers don't get much bigger than that. Let's see if this works. There you go. So you can see those connection points there, right? Well, each one of those connection points ties back to the actual manufacturer part. Inside of every single manufacturer part on the electrical side, there is circuit and terminal information. So based on that circuit and terminal information is exactly where those wires are going to route to, um, in your model, right? So wherever that point ends is where that wire is going to go. And for everybody asking what does 0_0 mean, well, that it's because this is SQL based. It's using this is circuit 1 pin 1 0_0. It's one of those I believe buttons, right? Those theory buttons you gotta click every once in a while when you're going through school. But 0_0 is pin 1 circuit 1, or circuit 1 pin 1, I should say. So that's one thing you have to do, and going through and add that in. You can use the routing library manager, and actually in 2022 they've actually pulled it out of the routing library manager, and now it is on just a functionality that when you click it, it'll be available on the left-hand side. All right, so besides the circuit, or the circuit information for each one of your parts that you add, and keep in mind those are now part of the feature tree for that particular model, so you don't have to do this every single time you open up that part. It's built into the part, so every time you use it, like I have multiple of the same exact one. I only had to do it to one and then just put them all over the place in my project here. So now that we've done that handshake between the two, we took a look at our connection points. Let's go ahead and route some wires. So inside of the SOLIDWORKS electrical add-in, we have two different options for routing our wires. Technically, I have a whole bunch of different ones, but the two main ones for routing wires are a SOLIDWORKS route, a full SOLIDWORKS route. It's going to give us the full thickness, or just a sketch route. If this is your first time routing, I 1,000% recommend you use a sketch route to start. Don't jump right in with a full solid route. You can, it may work for you, but most times you're going to want to delete it and go, I'm going to move this wire over here because I don't like the way it's coming around this bend here through this panduit. It looks like it's going through the bulkhead, and it takes a little bit longer to do the SolidWorks route than it does a 3D sketch route, right? So definitely, without a doubt, always start with a 3D sketch. It just helps, uh, do it, make some changes to your sketch, your overall sketch, which we'll see in just a second, and then reroute it. So besides doing 3D sketch, you have the ability to do splines and lines. I don't think I've ever used lines. I want this thing to look realistic, so I just use splines. Lines make it a little bit faster, kind of give you a quick down and dirty view of where things are going to go, but I want to see kind of realistically how this thing is going to bend. And then your routing parameters, right? Your routing parameters are important, and you may have to tweak them here and there based on how far apart your EW path, which I'm going to show in just a second, how far apart those are, your connection points are from this sketch line that we have, and how far apart you want each sketch line to be from each other. So I'm going to go ahead and say okay. And at this point here, I'm going to let the software do everything on its own. So what it's doing right now is it's looking at all the models, all the parts I have in my project here in my assembly. It's looking at the schematic and it's looking at all the circuit information in my schematic to try to map exactly where everything is and try to figure out where it should go based on, its own algorithm. So there is a wire. You mentioned the EW path, right? This high level sketch that we have, and we'll see it pop up here in a second. You might have saw a quick glimpse of it before. It was a yellow grid looking line that I had on there. I turned it off. Um, Now that is important. You don't have to have that, but I would highly recommend having that EW path in your project because you can route and you don't need that EW path. But if you don't put that EW path in, the wires are going to go where they want to go, not where you told them to go, right? So if you're trying to get it to follow a bulkhead or follow one of those cableways above a couple racks or something like that, and you don't put that in, it's going to go from point A right through the sidewall of a cabinet and go and try to connect to that other spot. Where in reality you want it to go up and around. So you have to put these. It's a 3D sketch. You put the 3D sketch in, and you turn it, you convert it into what we call an EW path, and then from there, the wires will follow that path as needed. You can see here that was pretty quick, right? I'm not going to count that quick there. It looks like 12 or so different wire styles that I have in my project. Maybe a minute or so, 30 seconds to a minute that we took that to route those sketches. So now at this point here, I would come in and say, all right, I don't like the way my ground lines are coming in along the side of the cabinet. Maybe I want to tweak those. So very simply delete those and start over again. Or you can go in and manually edit that if you don't want to have to go back and redo it. I will say a little asterisk next to that manual, like, right, you can edit those just like you could do with any other kind of sketch line. But if you delete anything and reroute or just hit reroute, it's going to delete anything you did manually. So if there's anything manual that you want to try to tweak, always save it to the very end where you're not going to want to go ahead and manipulate and change those sketch lines later on. So you can kind of see that yellow line, right? I wonder if you can see it up here. So this is the guideline that I had it set to that I wanted it to follow. You can kind of see it. It appears because I'm working with sketches, it appears because I turn my view sketches on up here. All right, so now that we have our sketches here, if you do need to make manual changes or tweak something and grab one, edit route and just drag something, use those, what are they called? I can't remember the name off the top of my head. It's the point, but then it has that arrow on it, right? Pull that out. You can move that around as needed. You do want to come in. There is an option under the SOLIDWORKS electrical tools, SOLIDWORKS electrical, and there is an option for update wire and cable length. What this does is it takes the information that you've got here. It happens automatically when you route, but if you edit any of these routes, you want to come in here and update this, and it will push that information back to the SQL database in SOLIDWORKS electrical, because we can go back into SOLIDWORKS electrical now and we can generate our reports. So in order to generate reports inside of SOLIDWORKS electrical, under the electrical project tab, there are two different types of reports. There's reports and design rule checks. And right now we're going to work with reports, but the difference between the two, design rule checks are, is there a voltage drop in the cable? Can I find out the fill duct ratio for this bulkhead? Am I using the wrong size wire for, maybe I'm using a 14 gauge, but the part itself that I'm working with says the max uh, wire gauge is only 16, right? So those are types of reports that you can have set up, and you want to check those periodically while you're working. The reports are usually you can build it ahead of time if you want, but most folks wait till the very end, generate those reports and push them out. In this case here, I'm simply going to go ahead and say reports, or click reports. There are a lot of different types of reports that we can choose from and customize, right? Because this is SQL, if you're good with SQL, I'm okay with it. I'm not the best, I'll admit that. But if you're good with SQL, there's a lot of different formulas and reports that you can create. And what I would recommend is take one from here, copy it or duplicate it. Don't just edit the original, right? Because then I got to send you a copy and I'm going to ask you, what'd you do your first one? But take that, duplicate it, and then mess with the duplicate. So that way, if you screw anything up with in the SQL side of the house, you can always delete it, grab that duplicate, grab that first one, duplicate it again, so you have that one to always fall back on. But you can see here, there's a lot of different types. And taking a quick look, a quick view here, we can see all the information that's built into these different types of reports. You can see that we've started to capture length for some of these in the wire styles. Without even adding it to a project, we have the ability to add it to an Excel spreadsheet or push it out to an Excel spreadsheet, a text file, or XML. So if you've created a custom report such as a wire label report, right? Maybe you want to just get the information that you're going to put on your wire labels. That's pretty much a to from wire list. Maybe it's whatever it may be. You can now export that to Excel or XML and push that to your Brady printer or Mitsubishi printer, whatever you've got, and that way you're not sitting in front of Excel manually typing all those things in to push into that printer later on. If you're going to add it to the project, you can go ahead and say generate drawings, just like we did with our terminal block drawing earlier, and let the software gather all that information up for you and put it into the project itself. So it's pulling a lot of information. So this takes an extra minute or so. But again, imagine trying to sit there and generate your to from wireless in Excel or your bill of materials in Excel, and doing all that manually, right? And then you know if you fat finger it and you mess up one of the numbers in there, like I've done in the past, um, you can go in and that can cause some issues. But this is capturing everything that you put into your project. All right, so taking a look at those different types of reports. I'm gonna close these guys out real quick. And we could take a look at, let's see what we got here. Here's one. So in this case here, I've organized it based off of manufacturer, not off of vendor. I know a lot of folks out there would rather see, I want to see all my Mauser parts and my DigiKey parts or my McMaster parts or whatever it is and organize them. You can do that as long as the metadata in there says that when I order this part, I usually order this from DigiKey and there's DigiKey's part number, right? So you can organize it that way. You can organize it based off of location. Maybe I talked about locations before. Maybe I want to see my top level. I want to see everything in my project. Or I want to create a bill of materials just for the cabinet or just the cabinet door, right? So there's a whole different ways you can capture that information here. Some of this information is hyperlinked. So when I do click on it here, it will open up that schematic and show me that part in my schematic as well. Other than the bill of material, and again, totally customizable. There's a whole bunch of different fields you can add. Same thing applies to our to from wire report, wire run list, whatever you want to call it. But it's your origin destination information. I did not number the wires. I should have done that first. I can go back and do that real quick. But you can see here that I have this type of wire, this black gauge, a 10 gauge wire, and it's giving me the length, the overall length, plus the total of that. So if I'm dealing with something like RF cables, right, where I'm buying them, depending on if I'm buying them custom, right, from I can't think of any of the vendors off the top of my head, but if you're buying them, right, you may want to get an idea of how many feet you need or inches or metric, right, how much you need for that project ahead of time, so you can kind of get an idea. Done a really good job with getting that done. I was working on a test project that had probably 200 wires in it, and it did route a lot faster than what I had done back in like 2016 or so. And then, of course, at the very end there, we automated our report generation. Remember, there's two different types. There's reports that have your bill of materials to from wireless, and then you also have your design rule checks, which is another type of report that you would not necessarily have part of the project, but you can just run them and see the kind of information that you're working with in your project. So SOLIDWORKS Electrical, the major pieces of the puzzle, the data reuse, the change management, design review, and of course, those reports. So if you are interested in more about SOLIDWORKS Electrical, that's going to take you to solidworks.com, the ECAD page. But if you're interested in more, you can always reach out to me. You saw my email address earlier in the slide deck, and then always reach out to. You got TPM and you got TriMech here with everybody today. So reach out to one of them. If you are also interested in doing this, we also offer myself, I run it, and my counterpart Thomas, his picture showed up on the screen earlier. We also offer an online hands-on test drive. I've been working with, so the folks from Trimec that are there, or if you're a Trimec customer, I've been working with Tim Pulowski a lot, doing that kind of stuff. But um, if you want, we run it through Amazon AppStream. Just reach out to me or reach out to your reseller. We can work together to get you up online. It's kind of a guided tour. You're actually using the same data set I just did, but a little bit more, just a slower pace, so everybody can kind of see the picks and the clicks and how everything works. So if you're interested, we can do that too. And then I know Heather mentioned it earlier, so this is actually her living room. So this is Earl's and Heather's brewing kit that they moved. We picked up and moved their kitchen table out of the way, and I assume he still has it, and he wheels this out of the closet and puts it into the dining room. And you can see that yellow cable in the back there. So there's actually a jacuzzi in the back, and with 220, he disconnects the jacuzzi when it's time to brew beer. And so we spent the day and we brewed some beer. You can see those carboys on the ground there that we're getting ready to start the whole process. And we actually did with this whole process here. And why a part of this was obviously a little bit of marketing too, right? I'm a tech guy working with some of the sales guys and stuff. So what we did is we kind of took this data set and we went to Earl and Heather's house with their dogs, and we brewed a beer in their living room. We made a whole video series on it. It's on YouTube. If you search SOLIDWORKS Electrical, Brewing with Electricity, SOLIDWORKS Electrical, you can find it. It's a 6-part series that you can search up. You can see my fat head right there, as we've got Earl Haas, we've got Brian Zayas, and Mark Martell. A lot of you guys probably know those 3 guys. They've been around the SOLIDWORKS community for many years, much longer than I have. But yeah, so that's just part of this whole show here. So with that said, are there any questions? Let's see. Does anybody have any questions? I'm trying to watch the YouTube feed here too. I've got the question thing. We're using GoToWebinar here, so the questions are coming in. Adam, are there any questions that you can see, or Mike? Let me take a look at YouTube real quick. I know I've got probably only a minute left here of my time. What was that? I couldn't hear it. It was kind of. As far as you create the 3D sketch and then back on the 2D side.
Yeah, so if you create the sketch and you put it and you push it back, are you able to get an alert notifying you that I guess it's done? Is that the question? That you
So
need to do it, or like that it needs to be done, or whatever.
there's no specific alert that pops up, but there is where is it? There is an option here for connected users, right? So if you do have a mechanical and electrical person working at the same team, working at the same time, you can send each other messages back and forth, like, hey, I've just added a new part, or hey, I need you to rerun the sketch, or hey, I need you to change this or that, or whatever it may be. You can either send it to everybody working in that project or just send a message back and forth between the two. And yeah, I don't know if it showed up earlier, but there's a little yellow pop-up window that will show up with the chat window on here. I can't do it to myself because it's just going to myself. Maybe I can. Let me try. Once they've changed that, let's see. I don't know if it's going to work. Oh, there we go. So it used to be yellow one, but they popped up. So now, like in this little window here, you could say, hey, I need you to change or reroute the sketches or change something, or I did reroute the sketches and I updated I changed the sketches, I manually edited them, I updated. Now you need to go in and just check the reports and make sure everything's updated on your end. There is a way on here too. there is an option for update, so you don't have to delete the report itself once it's in the project, right? Some people, when we first started using this, they were just deleting all the reports and rerouting them all, right? It took a few minutes to do that, but now instead of doing that, you can just simply right click and say update. And so the project will stay there. It's just going to requery and check everything and make sure everything's right, and update anything that needs to be changed as well.
All right, so I think that may be all the questions there for us, JP. We appreciate it for you sticking around and hanging out with us and giving this presentation for us. I know we've gleaned a lot of information off of it. Had a good question out there for it. So yeah, I'm super excited to see you at World. I know that's going to be a great experience out
Yeah,
there
it should
for
be
you. Yeah,
really,
it should be
really
really,
fun in
really
Atlanta
fun
this
in
year.
Atlanta this year. Definitely. And if I'm not mistaken, they may still be doing a call for papers. So anybody out there, if there is still a call for papers out there, you want to submit something, have an idea, it's a great opportunity to be able to do that, as well as just go and register. It's going to be a great time. So look forward to seeing you there, JP.